morning, everybody. Hopefully you can hear me at the back. So let's get on with the show. Let's see if this works. Maybe I'll switch it on. There we go. Okay, so I'm here working for ESA, but in fact, today I'm doing the marketing for ECSS. So ECSS is the European standardization. You can see that. So I'm not going to read every slide out, by the way, just to warn you. I believe you'll get the presentation after. So the ECSS is actually how Europe drives space industry for the bigger project, the space projects, okay? It's driven by a partnership of industries and space institutes, okay? What that means is that it's not just ESA working. So everything is done by consensus. And it's a consistent set of documents. So you read one document, it should match consistently what's happening elsewhere. And hopefully I'll make that a little bit clearer in a minute. I'm going to skip this. It's got an organization, it's got a clear structure, it's got a clear governance. You can all find this on the ECSS landing page, by the way, so don't worry if I'm going a bit quick. Can you start the countdown? Otherwise I'll be an hour, so. So the way ECSS works is you've got three main document types. Standards, normative documents, tell you what you have to do, but not how to do it. Then you've got handbooks, which is more guidance. Experts have given advice. You don't have to follow it, but it gives you advice on how maybe you can cover those requirements and more the how. And then you've got technical memoranda, which is not RFCs, but technical notes and advice. We try not to reinvent the wheel, okay? So we use existing and commonly used standards where we can. And ECSS, the important thing about ECSS is everyone gets frightened about ECSS because it's a big thing. There's a lot of documents, there's a lot of stuff depending what speciality you have, but you tailor it. You tailor it for your mission, you tailor it for your project, the size and type of your mission. And it's no different from this new security standard here. So why do we need security for space? I think it's pretty obvious maybe to some of you. So just to set a little bit of a context, it's a rapidly expanding domain. We've got major societal and financial value. And I think you'll identify a few of the points that you've seen yesterday, and maybe those who've been listening this morning as well. So it'll ring a few bells as we go through this, what we've been trying to achieve here. We're going to increase to common platforms, more use of COTS, constellations more and more. When I started in Europe, Galileo was the biggest complex constellation Europe had done. And it's only 36 satellites, only. But when you look at what Starlink's doing with thousands, Amazon's trying to do with Kuiper, it's a different world. Things are changing. Our eyes were opened with the, things like CYSAT, opened everybody's eyes that it's concrete, it's credible, it happens. And it's now been declared that space is the fifth warfighting domain. So everybody's getting more serious about it. So again, I like to use this slide just to give an indication. This is just, I stole this off the internet, but it's quite a nice indication of how the bar has been raised, and it's been increasingly raised over time, and the adversary capabilities are being increased as well. This is from a report last year, which is, I guess, the first real report we saw people trying to assess concrete attacks or empirical evidence of how things are changing. The size of the issue is not actually that well known. So you've got initiatives such as the Space ISAC, the EU Space ISAC declared yesterday, our threat intelligence sharing platform, bit of marketing there for the CSOC. And the market is growing massively, and we saw from the AI, the adversarial AI, not hopefully, but I think it will reduce the barrier to market. The big change, I think, has been software-defined radio. So for the space, we've been relying on, got big antennas, very complex system, bespoke hardware. Well, it's no longer the case. You can do it in your back garden. Paveur, a few years ago, he demonstrated in 3 months without knowing anything about space. He had a software-defined radio, and he did a really good talk. I'd recommend that from DEF CON 2019, I think. He did a really good talk about what he was seeing, what was published in the clear from most space projects. Okay, so There are already a plethora of different standards frameworks, okay? It's very confusing, sometimes contradictory, but they all have the same objective. They're all there to help us run a process, run an activity to manage and handle this problem of security. There are a number of formal national evaluations. So this is more the assurance side. How do you know what you're building is good enough? How do you differentiate a tool built overnight, over the weekend, maybe a personal endeavor, an open source tool, maybe very good, maybe very bad? How do you differentiate? This is what these national evaluations, I call it, try and achieve. So there's a lot of those. They're generally a very heavy process. The ones I think most people are familiar with, probably in the room, is common criteria and FIPS. So common criteria puts in place a process, 1 to 7 level process. So that's more on the assurance side of things. Space related. So those who went to see Ignacio's training yesterday on CCSDS would have seen all of this already. So it's quite a complex hierarchy. In fact, there's a working group in Washington, and for institutes wishing to work on an international level, not European international, but global international, CCSDS is the forum for that. NIST, so obviously this is the US-led initiative. They're quite open, which is quite nice for us because we gain a lot of information and knowledge from that. The CNSS, which is the National Security Systems, they publish some guidance, and they have for 20 years. So they've already got profiles for different types of missions mapped to the 853 standard as well, the federal standard. BSI, they've recently published 2 standards, the Grunschultz. The last one was quite easy to read, quite good advice in there. And then obviously you've got the adversarial frameworks. So you've got Space Shield, Sparta, and TREX. They're the 3 main ones I'm aware of in the space world at the moment. So there's quite a lot of things going on in space. So why do we need more standards? I mean, come on. Remember Massimo McCarthy was explaining yesterday, space is critical, and there's a need for homogeneous, transversal space components, secure design implementation, and it's not just for member states, but it's for industry as well. Okay. Matthew yesterday was pushing for improved standardization for space internet. I discuss, when I joined ESA, I came from industry. When I joined ESA, I was discussing with most of the project managers, and they did not understand the need for security. Times have changed. I speak to the same project managers, and they understand the need of the security, but they not understand if they can afford it. They cannot understand what the impact is on them delivering their cost and schedule. Okay? So our own regulations are quite clear, our own directives, but you can't see that. That's for us to use. For Europe themselves, the idea of ECSS is at least to put in place a first step. So this is a first step, this document, to give some consistency and guidance. So it's going to fit here. So this is the ECSS hierarchy: project management, product assurance, engineering, space sustainability. So that's how it works. We're going to fit down here under engineering. There was a lot of discussion about whether this should be a quality standard, an engineering standard. If you look down here, risk management. Well, security is about risk. Should it be a management standard? In the end, after some discussion, we're now going to be, in fact, we even talked about having another branch. Is security important enough to have a dedicated branch? Now, I think most people in the room would say, yeah, let's have a dedicated branch. But we're down here. This is where we're going to be, which for me is very good. I see it as an engineering discipline, not as a quality discipline. But this is always open for discussion, and we'll discuss forever. Okay. So ECSS has to support small to large mega projects. So what we're trying to build a one-size-fits-all set of standards. So it's not going to fit every project. It needs to be tailored for every project. And that's an important thing to think about. So don't be frightened. The document itself is quite short. It's 50-something pages, I think. So it's got about 30, 40 pages of content because we've got all the preamble. And it is a one-size-fits-all. But I'm sorry. So I think most people in the room, I'll be teaching you to suck eggs. We're not here to innovate. This standard is not to innovate. It's to try and put in place the best practices that everybody is using, or at least should be using, across our industry. So I think for most of you in this room, nothing here is a surprise. I'm glad I'm not now doing this at the end of the day, because most of you will probably fall asleep. But what I'll try and do is give you a little tour of the standard, okay, going forward. So it's good if you're not surprised and you're not frightened, because that is not the intent. It's there to give some consistency and some direction. So when you discuss with your management, with the decision maker, we have a clear, consistent message to make sure that we have some security in all space projects, because I think we'd all agree we need it now. Okay, let's go. So the new standard, it starts off with the terms and definitions. It has quite a long section on principles. You know, I've got a few notes here. You know, access control, authentication, least privilege, need to know. So yeah, please apply these principles. Then it's structured into 4 main areas: the organization, mission, security engineering, and assessment. So organizational aspects, let's look at that. Yeah, with the animation. Okay, there we go. There we go. Okay, so have an organizational security plan. So have an organization-wide plan. The thing is, you've got to think about, you cannot afford, if you're building a new CubeSat, you cannot afford to start from scratch. So your organization already needs to have a security culture. So what we try to do here is put in place some of the principles, some of the roles you need. Make sure that you have how you're going to handle sensitive information, whether it's unclassified, classified, or different levels, whether it's PII, so personal sensitive information, or whether it's just information that you think is important for you to protect. You know, so I've run out of time then, no? That's why you shut me off. Do I get an extension, Guillaume? Okay, so you're building the next cool satellite. You've got a really important bit of technology that you want to protect. Maybe you don't have a patent on it, but it's important to you. So at organization level, if you put that on the internet, you go to a talk like this and I present my latest technology and everybody copies it, well, you want to protect that. It's your value for your business. So at organization level, you put in place these basic rules, these basic processes. If you're looking at being credible as an organization, you will be looking at something like an ISO 27K certification. I know the big companies already have them, the small ones will struggle. We call it an ISMS. So put in place an ISMS, nothing is surprising here. 2 key roles are defined. Security manager, he is responsible to establish the policies and plans and supervise the implementation and risk mitigation. Security internal auditor, this is linked to the assessment side of the chain. They need to be sufficiently independent and especially reporting to the right level. If they see a major problem, they can let's say, discuss at management level, a bit like a safety. You know, in safety, they have an independent safety. So it's a similar sort of thing with the internal auditor. So they need to help plan the audit and assess that what is being implemented is in line with the overall approach. Where am I here? Yeah, this is the roles, key personnel. And put in place processes and tools for accounting all of this. Mission security. So this is the first, say, the organization is more transversal, so you'll apply that once and you'll just follow that process. And then you'll tailor that per mission. So each mission, you need to have a common sensitivity level. What do we mean by this? So different companies mark and label and handle information differently. Some might call something commercial in confidence. We call something limited distribution. Someone else might call it restricted, which we hate, but some companies do that. When you build your project, you need to agree a common terminology of how you're going to manage it. You need to agree how you will exchange things. In ESA, we call it an information security management plan. So you'll see in our ITTs, give us an information security management plan, tell us how you're going to match our equivalents and how you're going to handle it inside your consortium or your industry. So when you work yourselves, you need to understand a common way of handling security and exchanging it. So mark the documents, agree on the mission, how you do it. If you agree to handle it differently, because obviously different companies cannot necessarily relabel everything, agree in equivalence. Create a table saying, I mark this way, you mark it this way, you mark it that way, and we agree we share it in a secure way with these tools, with these methods. Okay? So to give yourselves assurance between each other. What other notes have I got here? Yeah, so when you're using shared resources, when we say shared resources, because we know that big space missions have hundreds of contracts, hundreds of contractors. So you're going to share resources. You need to make sure that how you share those resources are agreed at the highest level. So that the owner of that activity needs to agree how you're going to share the resources. Where are we? There we go. Mission security requirements. This probably, I would say, this slide, if you're going to take anything away today from a technical level, this is the slide. So I will read this out. So all communication links, space, telemetry, telecommand, mission specific, and terrestrial, ground segment and other shall, as a minimum, so this is the minimum bar we're setting, and I can tell it was a lot of discussion, because most people wanted to have encryption and authentication, okay? But we know that if you're on a science mission, maybe your risk profile is different. If you're a CubeSat, your risk profile is different. But here, maybe for some of the project managers, this is a bar that's higher than they normally expect. But this is the minimum, as Europe, we have to do. Use cryptographic authentication and integrity mechanisms, sufficient for the sensitivity of the highest information you've got on your mission, okay? So no surprise, but now it's in writing, at least we're setting the bar. One thing we say is do a risk analysis. It's all about the risk. So you can say, yeah, I do this, is it good enough? Well, it's good enough depending on your mission, depending on your risk appetite, depending on your risk tolerance. So do that at the mission level. Define your key requirements. Do your risk analysis. Tailor it based on your risk analysis. Do your confidentiality, integrity, authentication, and detection controls for your information in transit, at rest. Consider the physical element as well. Make sure if you're separating things physically, you cover that. Data flows and third-party access, because quite often now we're working as a team. We might be relying on third-party access. You might be outsourcing. Cloudifying, people are using cloudifying. Ground station as a service. You're relying on a third party, and they may have access into your system. So do you need to protect that? Are they doing enough for you? So if you take one thing away, this is the slide, okay? Where are we? Yeah, put in place measures. Know who has access to your systems. The mission security requirements are part of your mission policy. What you need to do is, basically you're breaking it down on other levels. So here you're at the mission level, so you don't necessarily have 1,000 requirements. You might have 30, 40 requirements. Nothing too heavy here. Screening of persons. Know your team. Screening is a very open word, but know your team. Incident handling. So it's no longer acceptable for the poor administrator to look at the logs from time to time, maybe once a week. He's overstretched, he's overloaded. The team needs to include security. They need to have a connection for security monitoring, okay? So on the big missions, you probably connect it to something like a CSOC. We've got our own CSOC for the agency. You might have your own SOC. You might outsource it. I mean, even within our organization, we do outsource some SOC activities at the moment. And I'm sure that will continue because there's expertise and it's not necessarily that expensive. But you need to do something to have an independent monitoring, to have independent expertise. Because in the project, it's very difficult, unless you're a mega project like Galileo, to spin up your own SOC. So you're going to have to do something. And this was a very easy discussion in the team, because it's common now. You have to do an assume breach posture. You have to assume that somebody will get into your system. You cannot rely on the castle walls anymore. I've got crypto, we're secure. No, you need defense in depth. So you have to put detection mechanisms in place. And it has to cover the full perimeter of the mission, not just the ground segment. Unlike the NIST, which talks about ground segment, here we're talking about the full end-to-end system. Okay, use threat intelligence, because you're going to have to prioritize. There are too many attacks ongoing. If you're looking at vulnerabilities, you know, it went from a few years ago, we were getting a few hundred, a few thousand vulnerabilities a year. Now we're into hundreds a week. If you've got a complex system of systems, you might have 300 or 400 COTS, and you've got to manage that. Okay. Then we go into system security engineering. Don't tackle it in isolation. Make it part of your process. Work with a system engineer. Have security experts, but work as a team. There are difficult trades the system engineer and project manager has to make. Security is just one parameter. Sorry to say, we think we're important, but we're delivering a mission at the end of the day. We're one parameter. Safety is one parameter. Operability is one parameter. We're part of that stream. We're part of the system engineering. Iterative and incremental. Okay. Start at the beginning. Full life cycle. So you're going from mission concept all the way through to disposal. Yeah, I'm not going to say anything. Create your requirements. Make sure you cover regulations. I think that is because I've run out of time, no? Put in place a maintenance patch policy. So here we start talking about put it in place for all your types of hardware and software. Define when your security patches are going to be applied. So put in place a basic policy you want everybody to follow. We don't tell you how to do it, we just tell you need to do it. Make sure you know where the patches are coming from. Make sure they're authentic, ideally cryptographically authentic. It's fairly standard now. You're no longer getting away with giving an MD5 sum. You might get an MD5 sum if independently you've got a separate channel to verify that MD5 sum is from an authentic source. So this is, I mean, it's standard stuff. It's already in the M40 for many years. Supply chain, it's important. We know it's important. Do it. It's a problem. Ensure you've got traceable bill of materials. Think about SBOMs. Know where your things are coming from. Know your full component supply chain. There are many risks on many areas around that. This is in the standard, this picture. Not the stuff on the left, but what's in the standard is this picture. And this is quite useful to sit down with your management and explain, we need to do this. Monica yesterday was talking about the need to have risk analysis. So we know risk analysis. This is again in the standard. It's a bit of a mixture of VBIOR, CYSO 27K. We just want to put something together to help understand the sorts of things you need to think about in terms of a process. Again, doing it over the life cycle. Your managers probably won't understand the 3,000 requirements you've got at component level. They'll never understand. The risk owner does not care. So try and keep, it's a recommendation from me, but you know, you need to start small. Start small, and as you iterate, but maybe keep some of the stuff that managers want to see as part of the reporting and traceability. So that's useful to take away. Make sure you do a residual risk analysis. You will have risks. You need to then do a risk treatment plan. You need to prioritize, and you need to get the risk owner. So we don't talk about accreditation certification per se, it's mentioned. We talk about a risk owner. Somebody needs to be responsible for the risk on your project. They're the ones who have to sign off that says, I accept that what you're giving me is good enough. Not perfect, it's good enough. It might be that it's borderline good enough, but you have a plan to fix things, because security is a process. It's not a solution. Okay, and then we get into assessments. Do a code review. Code review, static, dynamic analysis, fuzzing. I mean, you've heard it all today, loads of talks on that. Fix things before qualification, because you will be doing this, doing all the steps, and you will find lots of problems. So fix what you can before, because next time you run it, you're going to find new things, because it's a dynamic, changing environment. Make sure you audit what you're doing. Know what you're doing. Have a methodology. Know your scoring. CVSS is a classic one we all know for CVEs. So do that. Define it. Do it. So make sure, what else we got there? Yeah, correlate your inventory with known vulnerabilities. That's tricky. There are tools to do this for you, but it's not easy, I know. But it's improving now with chasm tools and things like that. What else have we got? Then we go into penetration testing. So you've done your vulnerability analysis, do penetration testing. Now, the word independent is used, so testers that are doing this need to not been involved in the design, development, or implementation of the system. The level of skill they need needs to be commensurate to your system. So you don't necessarily have to go and buy a dedicated testing house if you're a small CubeSat, but you need to do enough to give you confidence you've had an independent activity. So this is in there as well. Make sure they've got appropriate skills. So don't just have a normal tester like a software engineer doing it. Make sure they have the skills to do penetration testing. And it is a bit of specialist, I've got to say. And update your SRA. Yeah, make sure your security risk analysis is updated. You assign the priorities. If you're right at the right-hand side of your life cycle and you do the pen test, you might not have enough time to fix everything. But have a plan. Know the risk that you're accepting. Make sure the risk owner accepts that. This is standard ECSS sort of stuff. So this we added to just give an indication for those who don't know the process very well, how you might expect to do the main artifacts as the process goes over time against the system development lifecycle. And then you've got the other table, which gives you an idea, an indication. We had about 50 to start with. We reduced it down to this. And again, depending on your project, you might merge these in. You know, your system engineering plan with your requirements might be part of your TSD, your technical specifications document. Fine. You know, have a section, but make sure you tag which ones are security requirements. So this helps you there. And then the bottom one is important. We should have published already. We keep getting told it's next week, it's next week, it's next week. So I'll tell you, it's next week. Hopefully it's next week, but it's there. The last one that went for public review, we extended it because we changed the term. So that's available for you to download. You just look for the under review and you can download the latest version. We've implemented all the RIDs, the discrepancies raised by the public review. For us, it's ready to go. And again, I'd like to probably make a shout out there to Antonios, who is the leader of that. He took over because the previous convener, Juan Maria, had to leave. Antonios actually pulled everybody together and drove it through because it was drifting a bit. So it's a big shout out to Antonios there, who is also ESA, but it doesn't have to be ESA leading these working groups. So the next steps is we need to consolidate the standard. We probably need to align some of the other standards to make them more consistent, normal process. We're going to start writing handbooks and things like this to maybe support and flesh out this first standard to give more specific guidance in certain domains. But again, that's the next steps. And I'm pretty sure it will have to be updated. It's version 1. It's the first new standard, I think, in 10, 12 years for ECSS. So we think it's okay, we think it's good. It's a little bit different from other standards because we kept it maybe a little bit higher level because we're driving it forward. We need to drive security into the mindset, into the culture of everybody. And that's my last slide. So 8 minutes late, I do apologize.
Thank you, John. Great talk. We have just a couple of minutes for quick questions.
Yes, thank you very much. My question is related with the regulation. Yesterday, Guillaume told that there's going to be a regulation from the EU perspective. So how your work is linked with the regulation, please?
So we don't have visibility of the regulation in the working group, but as I said at the beginning, it's a combination of experts from industry. So everybody in industry is participating to this. It's by consensus. So we believe, and again, it's more of a framework. You know, we don't tell you how to do it, we tell you what you need to do. And everything there, we believe, will put you in a good position. If you follow the processes, maybe you have to tune a few things a little bit higher, hopefully not a bit lower, but we believe this sets a good posture for European industry. And again, we work a lot, ESA works a lot with America, and big companies all work across the globe. We know that if you're working with the US, you have to do it a certain way. Well, this is pretty much the same. Like I said, there's no surprises here, nothing super special. We're setting a bar. If you follow that bar, plus or minus, you're in the right ballpark. You can stand in front of commission and say, I'm doing the process. I know my risk. I have a risk owner, and he has signed off on that. It's good enough. It's not perfect. We have a process. So we believe we're in very good shape as Europe if we take this on board.
Okay, no, it works. We have one question online, kind of interesting. Okay, how can the mission security requirements for encryption and authentication be implemented while ECCS and CCSDS protocols do not support it? SLDS is just one layer of the stack, while SLE and CFDP do not meet these requirements.
So Milenko, unfortunately, you didn't go to Ignacio's training yesterday because it is there. It does cover AS256 GCM is the recommended baseline in 350.1 Blue Book. Okay, it's already there. So there is a baseline for industry. You can change it, you can use it, not use it, but you can encrypt, you can authenticate. It is there. Depending what layer of the stack you want to go, you can cover it. So Europe, we have it, and I think 2022, the 350 came out. So look at that, CCSDS, and it's the baseline I think we use in ECSS as well. I'm trying to see Ignacio is not there. If ECSS already refers to it, because again, we don't reinvent the wheel, we try and refer to other standards and other baselines. But it is there. We're in good position. If you follow that, we're in good stake.
Okay.
Shape, sorry.
Thank you. We have another question online. Okay. What is the foreseen timeline for applying this new standard in upcoming ESA projects?
Well, ESA projects that we apply internally, we already do this. You know, we do a risk analysis. Some of the activities maybe we don't do exactly as written here. We maybe tailor them to tailor them out. But I think if you picked up Massimo's presentation yesterday, the same question got asked, and he's my boss. So he's talking to the Director General. And it's clear that in current missions, we are where we are. Some of these missions have been going for 10, 15 years. They haven't launched yet. You know, you can't change the train. It can't pivot that quickly. So what is happening systematically is since 2020, we issued a new version of our internal directive. So on ESA missions, there is a mandatory requirement, and it's in the regulation as well, so you can see that yourself, that on ESA missions, we have to know the risk. Everybody has to know the risk in every directorate. The fact is, they may decide to accept all the risk, but they know the risks they're taking. They're going in with their eyes wide open, which is the most important message. If you've been running for 10 years, you see that the threats to your system are increasing, but you're willing to accept those risks. That's your choice as the risk owner. Now, your customer may be not happy, but do you want to delay your project by a year, 2 years, 5 years? Maybe, maybe not. Maybe it's going to cost you another 10 billion euros. It's unaffordable. So the ones that are already running, we have to know the risks. So we're reinforcing within the agency to do that risk, and independent, our office is doing that on ESA missions, on ESA-led missions. But again, a lot of ESA missions are done by industry. So effectively, we're funding industry and helping them. So it's industry will be effectively the risk owner as long as they comply with our minimum, let's say, contractual rules for handling information, managing information appropriately. So yeah, you can't change direction. There is no explicit timeline, but at least do the risk analysis right now. You have to do it right now. Understand what you're doing.
Okay, thank you, John. Do we have a question from the public? Okay.
Thank you for the presentation. You had several slides where I saw the standard ECS way of managing projects with all the milestones, CDR, PDR, and so on. How far is the standard compatible with the, let's say, different management approaches like agile management and so on? ECS taking care of that as well, I know.
Yeah, I mean, there is a dedicated agile standard for software, I think. So generally you follow it at software. It's a debate, no? And I run a few projects myself where we're following the waterfall life cycle. This is how ECSS generally does it. But underneath, you're following an agile approach. So a lot of this, put it in your pipeline. You know, put in your pipeline, you're doing static code analysis. Part of your release logic every day, you run automatic testing. Automation is the key when you're doing agile. So you have to, you know, you have to build the organization. You don't arrive to a project and spin up a full CI/CD pipeline overnight. So you have to have that available. But as part of that, your definition of done needs to include what are my security requirements for me to release this to pre-production, to let's say system qualification, because I don't think you can do system qualification as an agile activity per se. Maybe you can, but you're not going to do it every day. You're going to do it incrementally and iteratively. So your definition of done, you still need to know what requirements you have. It's a challenge. I think on a big mega program, you need to set some direction. So you need to do that initial, maybe you need a sprint to do your initial context. So put it as part of the first sprint, one of your sprints. Especially on a CubeSat or new space, you're probably going to be working that way, but automation is the key. And standard practices and tools are already there in the CI/CD pipeline because IT has been following it for years. Maybe we need to tune for the space system part, but maybe you accept the risk. If you're not using a hosted payload, you've got your own satellite flying, maybe it's enough to put in place, okay, I'm going to build the authentication on the link and not do anything internal, because I don't need to do anything internal, and then focus on the IT for the CI/CD part. So there are ways of managing it. We don't cover that, and maybe it's part we need to take away and start giving a handbook or something to recommend and guide. But again, we need industry to help us on that, because you're doing it. Because in ESA, the big programs need to follow waterfall. They're too big to not do it, I believe. It's my opinion. Maybe not everybody's opinion. I think Elon probably would disagree, no, with Starlink.
Okay, thank you again. We have time just for the last quick question.
Well, it's going to be a quick question. It's fairly straightforward. Does the standard define how often you need to do pen testing, or is that something that's always going to be mission specific?
It tells you what you need to set a policy. So you need to define it based on your risk. It does say you have to do it every major milestone. It does say that. So depending on how you do your milestones, you need to do it. But vulnerability is, I would say, more critical, especially on the IT, classic IT system. But yeah, it says every major milestone for the pen testing and vulnerability scanning.
Thank you.
Okay, well, thank you again, John. Great presentation and great talk.